You've seen the headlines, right? AI is about to revolutionize medicine, or computers are now better than doctors at spotting disease. It all feels a little bit like science fiction, and it raises this huge, maybe even slightly scary question for all of us. In the very near future, who or what is actually going to be looking at our medical scans?
I mean, this is the big one, isn't it? When you go in for an X-ray or a CT scan, is the expert reading it still going to be a person, or is a machine just going to take over completely? It's the question that's really at the heart of all the hype, and maybe some of the fear, too.
But here's the thing. The reality, as it almost always is way more nuanced and honestly way more interesting than the headlines want you to believe. The best way to think about AI in the exam room, it's not the new pilot. It's a highly, highly advanced co-pilot.
So let's get this crystal clear. The crucial point here is that AI isn't showing up to replace the expert, it's here to augment them. You can think of it as a powerful decision support tool, one that gives radiologists a kind of superpower to see more, see it faster, and with a whole lot more confidence. But how does it even learn to do that?
Okay, so to really get a handle on this tool, we've got to look under the hood. I mean, how exactly do you teach a piece of software to interpret something as incredibly complex as a medical scan? This is a skill that takes human doctors years and years of intense training to master.
Well, the magic behind all of this is a concept called deep learning. Think of it like this. Imagine you show a computer thousands upon thousands of pictures of cats. Eventually, using these special models called CNNs, it just learns to recognize the patterns, the pointy ears, the whiskers, the tail, everything that screams cat. Well, in medicine, we're doing the exact same thing. We just swap out the cat pictures for medical images.
The process itself is actually pretty simple to describe. First, you gather a massive, and I mean massive, dataset. We're talking thousands of X-rays or CT scans. Step 2, human radiologists painstakingly go through every single one and label them, marking every tiny fracture, every little nodule or bleed. And finally, you just feed all of that perfectly labeled data to the AI model, and it starts to learn the super subtle visual patterns tied to each condition, just like it learned to spot a cat.
So, okay, that's the theory, that's the training. But what does this AI co-pilot actually do when it shows up for work in a crazy busy hospital? How does it actually help out in a real-world clinic?
It basically performs a few key tasks. It can handle detection, which is finding tiny things a human eye might just glance over. It can do classification, basically giving a yes or no on whether a disease seems to be present. It can do segmentation, which is like drawing a super precise outline around an organ or a tumor. And maybe the most critical job of all, prioritization. It can flag the most urgent, life-threatening scans in a huge queue so a doctor sees them right away.
And this isn't some far-off future stuff. It's being put to work right now in some of the most critical areas of medicine. You can see here chest X-rays, head CTs for checking on things like brain bleeds, and mammograms for cancer screening. These are 3 of the biggest fields where these AI tools are already making a real impact.
Now, this is what's so fascinating. These aren't just concepts. These are actual products from real companies. You can see right here how tools from places like Cura.ai, ADOC, and Zebra Medical are each specialized for different tasks. They're built for speed, and they have the thumbs up from regulatory bodies like the FDA. The tech is already here. It's in the building. But, and there's always a but with powerful new technology, it's not a magic bullet. For every incredible promise, there's a potential pitfall that we have to navigate very, very carefully. It's a really delicate balancing act.
And this slide just lays out that balance perfectly. On one side, you've got these incredible benefits. Blinding speed, it's available 24/7, and it can act as a reliable second reader to double-check a human's work. But on the other side, you have very real limitations. There's the risk of doctors becoming over-reliant on it. There's the potential for false alarms or, even worse, misdiagnoses. And then there's something called the black box problem. This is where the AI can give you a stunningly accurate answer, but we have absolutely no idea how it got there. It can't explain why it thinks that little shadow is a problem, and in medicine, that's a huge hurdle.
All of which brings us right back to the most important component in this whole entire equation, the human. You see, these limitations are precisely why your doctor is and will remain absolutely irreplaceable in this process.
Look, an AI can see patterns in pixels. It can't see the whole patient. A radiologist provides the context, your medical history, your symptoms, your unique situation. They make complex ethical judgments. They understand that a scan is just one piece of a much, much larger human puzzle. And that, right there, is a job a machine just can't do.
So if you remember just one single thing from this entire explainer, please let it be this.
This is the absolute core truth of where we stand today. The goal here isn't to replace human expertise. It's to amplify it with an unbelievably powerful tool.
And that really just leaves us with a final thought to chew on. Knowing what you know now, that an AI can help prioritize the most urgent cases, that it can act as a safety net, a second check, how would you feel about it? It's not a question of man versus machine anymore. The real question is how we can best make them work together. It's definitely something to think about.